Now that we know how to check if functions are inverses of one another, let's talk about how to actually find the inverse. When we are finding the inverse of a function, we start by replacing f of x with y. So in this equation that we'll go through as an example, I'm going to write this as y equals 1/3 x minus 6. If it's already written as y, obviously you can skip that step. Second, we're going to swap x and y in the equation. So instead of y equals 1/3 x minus 6, I have x equals 1/3 y minus 6. So I'm swapping x and y, and now I'm going to solve for y. So I'm going to do whatever I need to get y by itself. I'll start by adding 6 to each side. And then I'll multiply everything by 3. And when I multiply everything by 3, that gives me 3x plus 18 equals y, or y equals 3x plus 18. Because it's an inverse, now I'm going to call this f inverse of x equals 3x plus 18. So this would be my final answer, is I would then replace y with the inverse sign. So remember that when we check them, I'm just finding the composition of the two functions, and I have to do it in both orders, f of f inverse of x and vice versa. So here for the first one, I'm finding f of 3x plus 18, which gives me 1/3 times 3x plus 18 minus 6, which gives me x plus 6 minus 6, which gives me x. And then if I check the opposite order, again, this is composition of functions, I'm finding f of 1/3 x minus 6, which means I'm finding 3 times 1/3 x minus 6 plus 18. When I distribute, I get x minus 18, and then of course plus 18, which cancels to give me x. And so yes, I did the math right the first time, and they are actually inverses of one another. The first thing I'm going to do is actually find the inverse of the function. And remember, to do that, I'm going to replace f of x with y, and then I'm going to swap the x and the y. I'm solving to get y by itself, so I'm going to start by subtracting 2 to each side, and then dividing by 3, which gives me y equals x minus 2 over 3. Some people would prefer, of course, to write that as x over 3 minus 2 over 3, and that's completely up to you. I'm going to leave it like this, which means my inverse function is x minus 2 over 3. Now I'm going to double check. So I'm going to find f of f inverse of x, which means I'm finding f of x minus 2 over 3. So in my function f, I'm replacing x with x minus 2 over 3. Everything else stays the same. These 3's essentially will cancel, which gives me x minus 2 plus 2, which of course gives me x. And then I repeat the process, composing them in the opposite order. And again, I'm hoping that I'll end up with x again, so I'm finding f inverse of 3x plus 2, which means in my numerator I now have 3x plus 2 minus 2 all over 3. The plus 2 minus 2 cancels. That gives me 3x over 3, which reduces, of course, to x. And so we have correctly found the inverse of the function. On the last two examples, I want to show you not only how to find the inverse, but then also what it looks like on the graph. So as you can see, this is similar to what we've been doing. This one will be a little bit trickier because we're dealing with a rational function, but I'm still going to find the inverse in the same way. I'm replacing f of x with y, then I'm replacing x with, or y with x, and x with y, and I need to get y by itself. So this is trickier because there are now two y's. So I will start by multiplying each side by y minus 1, and obviously what that does on the right side is it cancels out the denominator, which leaves me with xy minus x equals 2y. I want to get all of the values that have y over to one side. So I'm going to subtract 2y from each side, which gives me xy minus x minus 2y equals 0. But I really don't want this x here. Now I want to move that x over to the other side by adding it to each side, which gives me xy minus 2y equals x. So notice what I've done is I've now collected all of the terms that have a y on the left side. And the reason I did that is now I'm going to take a y out of both terms, so I'm factoring out a y, which leaves me with y times the quantity of x minus 2 equals x. To get y by itself then, I'll divide each side by x minus 2, which gives me y equals x over x minus 2. This is my inverse function, and of course I would write that as f inverse of x equals x over x minus 2. And then if I were to graph that function, notice what has happened is it really doesn't look all that much different, but I want you to pay close attention to the line, which I'm trying to draw here, which is the line y equals x. So the inverse of a function should always reflect the original function over that line. So as we can see, the red line was the original line. I can see that that line has now been reflected here on the blue. This red line has been reflected over to this part of the blue line, and vice versa. So we can see that the red line has been reflected over that line to become the blue line, which is in fact our inverse. One of those for you to try. The function is already graphed. You don't have to graph it yourself. I'll show you the graph at the end, but please do find the inverse of the function. Again, I would start by replacing f of x with y. And then I'm replacing y with x and x with y. Again, I need to get all of the terms with y onto one side, but before I do that, I don't like that I have a denominator. So I'm going to multiply each side by y plus 3, which is going to get rid of the fraction. On the left side, I'll distribute, which gives me xy plus 3x. On the right side, I just have y minus 3. As I did before, I get all of my y values to one side, so I'm going to subtract y from each side, which gives me xy plus 3x minus y equals negative 3. I'm going to get rid of this value that doesn't have a y by subtracting 3x. So I have xy minus y equals negative 3x minus 3. Again, all of my terms with y are on one side, so I'm rewriting this as y and then x minus 1. Then I'm going to divide each side by x minus 1, which gives me y equals negative 3x minus 3, all divided by x minus 1. Likely, if I were writing this then as an inverse, I would go ahead and factor out that negative 3, which would make it negative 3x plus 1 over x minus 1. And then if I were to graph that function, again, I want you to notice this line here in the middle, that the red line was my original, but I can see that this red line was reflected over here to this blue line, that this red line was reflected to this blue line.